Assalamu alaikum warahmatullahi wabarakatuh. My name is Hussein Shafi Muhammad. I'm from RK53. This is our members group, and our member title is Automatic Vehicle Control System. So, what is vehicle? Vehicle is a machine that used to carry people or goods from one place to another. Okay, first introduction. Automated control of a passenger vehicles is one promising method of increasing traffic density and efficiency on existing highways. Most schemes will require extensive use of wireless communication for coordination of maneuvers, staple control, safety, traffic advisories, navigation, and fault control. Software and mechanical hardware are seamlessly integrated in this project. Once a person sits on a vehicle fitted with this kit, he can be assured that he will reach his destination safely. Moreover, this system can be suitably changed so that it is used in a different setting. For example, we can feed in a particular map into the system so that it can be used only in that particular area. To explain this, let's consider a handicapped person sitting in a wheelchair fitted with this kit. He will be able to go to any room of his house without bumping into any object by using this kit. Aim and objective. The main objective is to test two decision algorithms for priority conflict resolution at intersections so that a vehicle autonomously driven can take their own decision about crossing an intersection, mingling with manually driven cars without the need for infrastructure modifications.
Assalamualaikum. I'm Ahmad Fikri Indisal. I'm from IT92. I will present my part, which is the advantages and problem statement. The advantages of control system: smooth traffic flow due to lane driving. Speed is maintained at a constant 30 km per hour. This speed is fast enough for traveling and slow enough for the driver to escape unhurt in a highly unlikely accident. Driving for the physically challenged. Transport of goods and personnel in sensitive areas like industrial hazard areas or even in large companies. Accident prevention due to automatic collision control. Only a few components are added to get all these extra advantages. Extremely cost-effective. Easily implementable as the parts required are available in any garage. The problem statement: based on our zone control model, a traffic control strategy is proposed, which decouple the motion conflict resolution among the AGVS from the routing problem. A routing algorithm is also constructed with the goal of minimizing the vehicle travel distance and the transportation time. The efficiency of the integrated design and control is demonstrated by computer simulation in terms of a set of defined measures of system performance.
Assalamualaikum, my name is Aimo. I'm from RK53 Communication Engineering student. For our project here, this is my part. I would like to explain about result and discussion. So in this project, our questions about driverless vehicles can be used in the warehouses, airports, and many other applications. Open loop transfer function of an automatic vehicles control system is given by the equation GS is equal to KV over S multiplied S over pi plus 1 square. So we have to use two steps, and first step is we need to draw the workflow of the system and determine the gain and phase margin of the system. Let's assume KV is equal to PI. And the second step is we are required to design and compensate a lead or lag so that the phase system would be at least 30 degrees. After that, we have to produce our design. We are allowed to use Scilab or MATLAB for our work. So this is the given equation for our transfer function. Gs is equal to kv over s is multiplying s over pi plus 1 square. So now when we try to proceed our equation, we will get Gs is equal to V out over V in, and is equal to pi over s is multiplying s over pi plus 1 square. And so after that, we will get 3.1. We trying to substitute the value of the pi. We will get 3.141 over 0.10 S2 plus 0.63 S2 plus S. So the final calculation for our above equation is 3.1416 over S is multiplying 0.73 S plus 1.
Assalamualaikum, my name is Ahmed Ali Ghazi, and today I will explain for you how to solve the previous question that been discussed by my friend using the Scilab, and we will show also the phase margin and the gain margin and how we are gonna design in the following video. Thank you.
Okay, so now we will write the Scilab code to solve our equation. So first we define the S parameter, so our Scilab can recognize when we put the equation. Then after that, we have to input our numerator and denominator. First we start with the numerator, which is pi with 3.1416, and denominator, which is the equation S multiply by 0.73736 multiply with S plus 1 to the power of 2. Now we can start our transform function using the sysline command by the Scilab. We input our numerator and denominator, and then after that we can show the bond plot for our transform function, which is shown here in front of us using the Scilab. Okay, after that we can show the phase margin and the gain margin also by using this command. And as we can see here, we got the blue line and the red line to show the gain and the phase margin for our transfer system. And for this, now we can calculate the phase margin and the frequency by using this command. And it will be equal to guess we have a mistake in the code here. We just okay, it's good. Okay, so we enter this command to calculate these values. We better type back again some glitch. Equal underscore 19 TF. Again, we have to be careful about syntax because Scilab does not accept you make a syntax mistake. As you can see, we got our GCF and PM here in these values. And as we explained here in the So at the end of this project, we can say that collision detection and avoidance system should become more commonplace with the passage of time. People are living in a networked world and constantly feeling that they have less time on their hands. It has been jokingly said that the more developed a country is, the more time its citizens waste behind the steering wheel. To perfect this technique, it might take several years, but this project is surely a step in the right direction. This project is a very feasible, as very less expensive parts are used. The most expensive component is the microprocessor, which is available in the second-hand market at a very low cost. This project can be improved upon in many ways. For example, including an overtaking feature, hopefully will be implemented in the future.